Today we're looking at special right triangles, specifically 45, 45, 90 triangles. And before we get into that, we need to look at perfect squares and simplifying square roots. So to simplify a square root, you need to factor the numbers under the radical so that you have one perfect square and another number. What I mean by perfect square, 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. 10 squared, 10 times 10 is 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is 144. 13 squared, 13 times 13 is 169. 14, 14 times 14 is 196. 15, 15 times 15 is 225. Now, that group, you should really have memorized, and it will help you a great deal know those just straight off the top of your head. These next few, you will likely see them, but not as often as the ones we've just done. So 16 squared, 16 times 16 is 256. 17 squared, 17 times 17 is 289. 18 squared, 18 times 18 is 324. 19 squared, 19 times 19 is 361. 20 squared, 20 times 20 is 400. 21 squared, 21 times 21 is 441. 22 squared, 22 times 22 is 484. 23 squared, 23 times 23 is 589. 24 squared, 24 times 24 is 576, and 25 times 25 is 625. So again, 2 through 15, you should really know off the top of your head. I'll make it easier for this unit. The rest of them, you may just want to have them and keep them in mind. So next up, looking at simplifying our radicals. Leave this up here. We have the square root of 27. So we can take and factor 27. So we have 9 and 3. Most of the time in this class, you're either going to have a 3 or a 2. So it's 32. You can factor into 16 and 2. Always check 2 and 3 first and see if what you get when you divide by 2 is a perfect square. What you get dividing by 3 is a perfect square. So on square root of 27, it factors to 9 and 3. That gives us the square root of 9 times the square root of 3. Leaving that square root of 3 out and behind, we're dealing with that square root of 9. Because this square root of 9, we're actually going to take the square root of it, and we get 3. Same thing happens over here. So we have the square root of 16 times the square root of 2. That square root of 2 stays. We're just dealing with the square root of 16. We take the square root of 16 and it becomes 4. So our next problem we've got is 75. So 75, is it divisible by 2? No. Is it divisible by 3? Yes. When we divide by 3, we get 25. 25 is a perfect square. So we're going to take the square root of 25 times the square root of 3. We're going to take that, actually take the square root of that 25. Square root of 25 is 5. So our answer is 5 times the square root of 3. Going to keep doing that same thing. We're looking at 18. 18 is divisible by 2. Yes. And what do we get? 9. 9 is a perfect square. You need to check the list. If it's not on that list, you go to your calculator. And you go, hey, let me take the square root of that. Square root of 9. It's me 3. So we're taking the square root of 9 times the square root of 2. As we've already said, the square root of 9 is 3. So our answer is 3 times the square root of 2. Our next one, we have square root of 108. Is the square root of 108 divisible by 2? Yes, it is. Or is 108 divisible by 2? 108 is divisible by 2. And we get 54. Is the square root of 54 divisible? Get us a perfect square? No. So we don't want to stop at 2. We're going to take 108. Is it divisible by 3? Yes. Is 36 a perfect square? Yes. We get 6. So we've got 36 and 3. 36 is my perfect square. Taking the square root of 36 times the square root of 3. And the square root of 36, as we said, is 6. So our answer is 6 times the square root of 3. Our next example, we've got square root of 48. It's 48 divisible by 2. It is. When we divide 48 by 2, we get 24. Is 24 a perfect square? No, we've got a decimal. So we don't want to stop at 2. We need to check, is 48 divisible by 3? It is. Is 16 a perfect square? It is. So we've got 16 and 3. 16 is a perfect square. So we've got the square root of 16 times the square root of 3, taking the square root of 16, and that gets us 4 times the square root of 3 for our answer. Next up, we have square root of 50. The square is 50 divisible by 2. Yes, it is. What do we get? 25. Is 25 a perfect square? Yes, it is. So we're taking the square root of 25, the square root of 2. What is the square root of 25? It's 5. So our answer is 5 times the square root of 2. Next up, we've got square root of 98. Is 98 divisible by 2? Yes, it is. And it's 49. And 49 is a perfect square. So we're taking the square root of 49 times the square root of 2. What is the square root of 49? It's 7. So our answer is 7 times the square root of 2. Now we're going to look at simplifying radicals when they're in the denominator of a fraction. So a fraction is not proper when you have a radical in the denominator. To get the radical out of the denominator, we have to multiply by a special number 1. What I actually mean by that is we are multiplying by whatever that number is, square root of it in both the numerator and the denominator. Because when you divide a number by itself, and when it's radical, it equals 1. So we're going to multiply by the square root of 2 over square root of 2. When we multiply fractions, we multiply across. So that gets us 12 square root of 2 over square root of 2 times square root of 2. So 2 times 2 is 4. So square root of 4. So what is the square root of 4? 2. So we've got 12 square root of 2 over 2. Then we need to see if that 12 is divisible by 2. And it is. So that gets us 6 times the square root of 2. That is our answer. So every time on these, you multiply both the numerator and the denominator by whatever was in your denominator. Then you will end up seeing at some point, hopefully, that whatever number was in that radical is the number that you divide by. And then you check and see if you can divide. If you can, you do. Can't, you leave it as a fraction. Our next one, we've got 7 over the square root of 2. So again, we're multiplying by square root of 2 over square root of 2. That gets us 7 square root of 2 over the square root of 4. Square root of 4 simplifies to 2. So 7 square root of 2 over 2. 7 divisible by 2? No, it's not. So that means that my answer is 7 square root of 2 over 2. Our next one, we've got 5 square root of 3, 5 over the square root of 3. So we're going to multiply it by square root of 3 over the square root of 3. Again, we're multiplying across. So that gets us 5 square root of 3 over the square root of 9. Because 3 times 3 is 9. We're taking that square root of 9, which is 3. So 5 square root of 3 over 3. Is 5 divisible by 3? No, it's not. So that is my answer. And our next one, multiplying again by the radical, square root of 3 over square root of 3. Multiplying across, so that's 9 square root of 3 over square root of 9. Taking the square root of that denominator, we have 9 square root of 3 over 3 is 9 divisible by 3. Yes, it is. So that means we divide, so we get 3 square root of 3, and that is our answer. So again, multiply by whatever is in your denominator, multiplying across. You end up with the number that was in that radical. Check and see if you can divide the number in front of the radical. Now we're going to look at 45, 45, 90 special right triangles. And again, 45, 45, 90 special right triangles refers to the angle measures. And we've got 2 of these kinds of special right triangles. We're just focusing on 45, 45, and 90 special right triangles today. And we'll look at the other one tomorrow. So most of y'all will say, let's just use Pythagorean theorem. And we can. We got 6 squared plus 6 squared equaling y squared. 6 squared plus 6 squared, so 6 squared 36 plus another 36, that's 72, equals y squared. Take the square root, and we get a decimal. But we can factor and get 36 and 2. And if you take the square root of 36, it gives us 6 times square root of 2, our value for y. So you'll notice that 6 was our side length. So we've got a trick, essentially, for whenever we have 45, 45, 90 triangles. So I don't have to go through all of this. All I need to do is notice that it's a 45, 45, 90 triangle, and that I'm going to label my hypotenuse because it's a right triangle. And my hypotenuse, when I have a 45, 45, 90 triangle, is x times the square root of 2. So I'm going to label it as x times the square root of 2. And my other two sides are both x. My two legs are both x. In a 45, 45, 90 triangle. So again, label, label, label. Label your hypotenuse. Tell me that it's x times the square root of 2. Label your two legs. Tell me that they're x. So that's what we're going to do. We're going to solve for our missing sides. So we've got a right triangle. I know one angle is 45 degrees. That means my other angle has to be 45 degrees. Side across from the right angle is hypotenuse. And that means that it is x times the square root of 2. That means my other two sides are both x. And I already know what x equals. We got it, it's labeled. So that means that I can go over down here and say that this side also equals 7. And I can come up here and plug that 7 in for x. So that gets us 7 times the square root of 2. So I've got my answers. 7 square root of 2 for my hypotenuse and 7 for the other side length. Our next one, I know I've got a right triangle, and I know that these two angles are congruent. The only way for me to have a right triangle and these two angles to be congruent is if I have a 45, 45, 90 triangle. So again, I can label a triangle from there, cross from my right angle is my hypotenuse, and it is equal to x times the square root of 2. And that means my other two sides are both x. Hey, I already know what x is. X is equal to 10 times the square root of 2. That means I know what my top side equals. It equals 10 times the square root of 2. And that's that side length. Now, I need to plug that 10 square root of 2 in for x. So that's 10 square root of 2. And some of you are going to say, that's it. No, it's not. We have to plug in 10 square root of 2 times the square root of 2. So 10 times square root of 2 times square root of 2. So square root of 2 times square root of 2 is equivalent to saying 10 times the square root of 2 squared. Remember that those cancel each other out. So that's just 10 times 2, which is 20. So that means that my hypotenuse is 20. That's my other part of my answer. And our last one, our last one, we know we have a 45, 45, 90 triangle. So we're going to label it. Across from a right angle is our hypotenuse. And it is x times the square root of 2. That means the other two sides are both x. So this time I don't know what x is, but I can solve for it. So we're going to divide by square root of 2 on both sides. So that gets me x equaling 16 over square root of 2. But that's not simple. So I need to multiply by the square root of 2 over square root of 2. And that equals 16 square root of 2 over square root of 4. And the square root of 4 is 2. So that gets me, means that I need to look and see if 16 is divisible by 2. And it is. And that gets me 8 square root of 2. So that means that my two side lengths up here are both 8 times the square root of 2. So again, please make sure you label your triangle. Start with your hypotenuse. It's x times the square root of 2. Your two other sides are both x.